All right, good morning, everybody, and welcome to the first lesson in pre-calculus. The first unit that we'll look at in the next week or two is all on coordinate geometry. And specifically, to begin with, we're going to talk about linear equations. Now, the nice thing is, I don't think you're going to learn anything new today, all right? I just want to review all these different things that you have seen over the last 5 to 6 years when it comes to lines. So let's start here. We know a linear equation is an equation whose graph is going to form a straight line. Now, at any point, all right, if I start moving too fast, you might not need to hit the pause in order to write down, some definition or some problems. No problems with that, all right? I'm just going to keep going through, so you might have to pause it in order to keep up. How do you know when an equation is a line? We have all these equations that are out there, all right? And there's one characteristic that really makes it a line. If I give you the equation y equals 3x minus 7, most of you understand that's a linear equation. The graph would be a line. If I give you y equals 3x squared minus 7, I'm hoping most of you realize that's not a line, all right? Because that square makes a difference. But then when the equations start morphing a little more, how about an x cubed plus a y equals, how about a y squared is equal to 7? Not a line either. How about y equals the sine of x? Not a line. How about y equals the natural log of x plus 5? Not a line. How about pi x plus ey is equal to 12? That is a line. So what's the characteristic that makes lines lines? And what you want to look for is you want to look at the two variables, all right? And when I say the two variables, I'm talking about the x and y's here. Above the y and above the x, you should have the number 1. You should have an exponent of 1. That's what makes a line a line. There are no other exponents, all right? You can have exponents, you can have different numbers as the coefficients in front, right? But you just can't have it as the exponent. This one had an x squared. It told us it was a different type of equation. This had an x cubed and a y squared. It was a different type of equation. Now over here, I have an x to the first, but because this is one of the 6 trigonometric functions, because there's a sign in front of it, that's how we're going to recognize that's a line. And the same thing happened here. On natural log, that does something else to the equation. So even though I have an x to the first and a y to the first, the natural log is what makes it not a line. And in this one here, I said this was a line. And it's because you have an x to the first and a y to the first. All I did with pi is I put the number 3.14, 159 on front. And e, if you don't know Euler's number, all right, you're going to learn that. You'll be using it several times this year. And it's 2.71828, and then it keeps going on from there. So it's really just like a number 3 and 7 that I have up here. All right, so that's what makes a line a line. Look for those exponents of being a 1. Now, there are 3 forms to a line that you guys have seen over the years. The first is called the general form. This is the least useful version to a line. The general form, 5x plus 6y is equal to negative 11. I don't know the slope. I don't know the y-intercept. I don't know the direction of the line. I don't know how steep it is. There's not a whole lot that I have. This is the form that you're given a lot, though, because the general form tends not to have fractions or decimals. And if you want the other 2 versions of the line, they tend to have fractions or decimals in them. The second version, slope-intercept, right? This is actually the first version that you ever learned about. The M represents the slope. The B represents the y-intercept. And in the last version, this is the point-slope form. The point-slope form has the slope to it, but then you have an x1 and a y1 here, and the slope x1, y1, and that represents any point that's on the line. As it turns out, this is the most useful form to a line that we have. This is the one that you guys are going to use most of the time because it's one of the easiest ways to come up with the equation. In fact, anytime I say I'm looking for the equation of a line that has the following characteristics, 2 and 3, the slope-intercept form and the point-slope form, these are the ones that you're going to use. And most of the time you won't use the slope-intercept just because you won't use number 2, just because there's not enough information. But there's always going to be information to use number 3. Okay, so let's talk about a couple formulas that help us when we're either dealing with lines or possibly line segments. In the picture up above, I have 2 points. I have 2, in this case, endpoints. All right, the first endpoint I'm calling x1, y1. Second endpoint, I'm giving the coordinates of x2 and y2. If I want to know the distance between those 2 points, I've got to use my distance formula. All right, again, I don't think this is new to you. I think you've seen it. What you might not realize is this distance formula is just a version of the following formula. A squared plus b squared equals c squared. It is Pythagorean's theorem. It's Pythagorean's theorem, but what we've done is we've solved for c. Let's see, to get the c by itself, I'd have to take the square root of both sides. That would leave me c equals the square root of, do that right, square root of a squared plus b squared. That's his formula. The c is really the d. A is x squared, x2 minus x1, and b is y2 minus y1. Now, how do we get that? If you come up to the picture where I have my x's and my y's here, if you actually drew a horizontal line and a vertical line, all right, that would connect all the points together, you get a right triangle. I call this side A, I'm going to call this side B, and my hypotenuse I'm going to call C. That's what we normally do. If I'm looking for the distance of A, I would have to know what is this y value here. I would have to know what is this y value here, and I would have to subtract the 2 to see what's left over. That distance between x1 to x2 is my A value, and that's where this is coming from. All right, and then the same thing with the b's. If I subtract the y's, y2 minus y1, I'm going to find out what the b is. So this distance formula that you guys have been using for a couple of years is really just Pythagorean's theorem, but somebody's hidden it on you. All right? In fact, I have a lot of students who they don't even use the distance formula because they would rather use Pythagorean's theorem in both this class and the calculus class. So what they do is when they have these 2 points and they're looking for the distance between them, they'll draw that horizontal line, they'll draw that vertical line, they'll find out the distance down here, I don't know, maybe it's 7, they'll find the distance over here, maybe it's 3, and then they'll plug it into Pythagorean's theorem and figure out, let's see, 49 and 9 and 58 square root of 58, all right, for that distance formula, or for that distance. Okay, second formula, the midpoint formula. This is if you're looking for the exact middle between 2 points. And in coordinate geometry, we are looking for it. All you got to do is average the x's and average the y's. All right, to average, you add them together, divide by 2. Average the y's, add them together, and divide by 2. If you're going to miss a problem, this is where you might miss, because most of these formulas have a minus sign in between the x's and a minus sign in between the y's, but that's not what the midpoint formula has. It says average them. All right. Also, if you notice, we use a capital N to represent the midpoint. All right. The third formula is the slope formula. It's the rise over the run. It's the change of y over the change of x. There's several versions to this. There's several ways that you're going to be able to find slope by the time you're done with this class. We're going to go with the most basic one. All right, you can either read it from the graph or you can use this quick little formula. Now, the first thing that you're probably thinking is isn't it supposed to be y2 minus y1 and x2 minus x1? And the answer is no, even though that's the way that you tend to see the formula written. You just have to be consistent. If you decide to find the slope and start with this point and subtract to the other point, whatever y you start with, you got to start with that x. If you had decided to start at this point and subtract y minus y and x minus x, you just got to be consistent, all right? So it really doesn't matter which way this formula is written. Okay, so let's do this real quick. All right, I'm going to take these 2 points. You do not have to graph this out. All right, I'm going to sketch it out. I'd like to take these 2 points and find the distance between them, the midpoint, and the slope between them. -6, +3, you put me right here. There's my A, and B is a +2, 1, 2, 3, 4, -4, which will be down there. Okay, so let's start by finding the distance between these 2 points. Now, here's where pre-calculus changes from most of the algebra and the geometry classes that you've taken so far. You can write as much or as little as you want at this point. This isn't a Regent class. At the end of the year, it's not like somebody's going to grade your final and they're going to make sure you have every little detail that the state is looking for. Because again, it's pre-calculus. The state doesn't have an exam. It's all going to be a local exam thing. So some of you are going to say, well, you know what? I sometimes mess up with the adding and subtracting. So I'm going to take each of my numbers up here and I'm going to carefully plug them into the distance formula. -6 take away 2 squared plus, let's see the y's, 3 take away -4 squared. And I'm fine with that. All right. Some of you are going to say, you know what? I'm pretty good at adding and subtracting. I'm going to do the addition or subtraction in my head and then write it down. D equals. So you are going to come up and say, -6 take away 2 is -8 squared plus, and then you're going to say 3 take away -4. The distance between 3 and -4 is 7 squared. Now, you're going to get the same result. The question is, how confident do you feel by doing that versus writing everything out? And again, to me, it doesn't matter which way you do that. So distance equals the square root. -8 times -8 is 64. Plus 7 times 7 is 49. And that gives me the square root of 113. Square root of 113. If there's a good house, bad house, all right, if there's a perfect square that goes into 113, you need to simplify. In this case, there isn't, so we would just leave that as our answer. As I was stating, I have students who will draw the horizontal, the verticals, and connect them. And then they will count. Let's see, this side over here. 1, 2, 3, 4, 5, 6, 7. This side is 7. How about my base? 1, 2, 3, 4, 5, 6, 7, 8. And so they will say, well, 7 squared plus 8 squared equals my C squared I'm looking for. If you notice, that's really what we had back at this point. It doesn't matter to me how you find the distance, all right? I do want you to be kind of quick with it, all right? But I want you to be accurate. Too soon. I need this slide. All right, so let me get rid of some of this extra stuff here. Got rid of my graph, but I can put it up again. Okay. How about the midpoint? I'm looking for my midpoint. If I had several points that were on this graph, I might do something like this. Capital M and then a lowercase ab, just so I know I'm looking at the midpoint for AB. So the midpoint for AB we just had to average the x's and average the y's. So to average the x's, my x is -6 and 2. Anybody know -6 plus 2? -4. And then half of that is -2. I added the two x's and I divided by 2. I didn't have to worry about writing it all out because it was simple enough math. 3 plus -4. 3 plus -4 is -1. -1 divided by 2 is -1/2. There's my midpoint. Now, don't be fooled. I gave you some nice numbers here. You know, do you think you can ever get a point that would have fractions or decimals in it? Of course you can. Mixed numbers, it could be harder than just adding and subtracting some whole numbers. And finally, let's find the slope to AB. Y minus y goes in the top, x minus x in the bottom. So up here, my two y values, 3 and -4. Now I'm going to be careful here. 3 take away -4. And then my y's, I've got to start over here at -6. -6 take away 2. 3 minus -4 gives me 7. -6 minus 2 gives me -8. The slope has to be -7/8, which does make sense because it's negative. It should be going downhill. 7/8 is very close to 1, all right? So I should have a slope of about -1, and I would say that was pretty good. You can write this as -7/8, all right? You can write it as -7/8, all right? All three of those say the same thing. You just got to make sure you only have one negative sign. Okay, so there are certain slopes that you should always know. So let's talk about these. So the first one is a slope of 0. We know a slope of 0 means that you have a horizontal line. If you're given the graph, you know right away that the slope is 0. If you're given some points, maybe you plug it into the slope formula and you end up getting like 0/5, which gives you 0, and then it's telling you that you have a flat line. No slope. No slope is when you have that vertical line. If you're looking at it, you should be able to say, oh, it's vertical. That's an example of no slope. If you're using the formula, maybe what's going to happen is you subtract the y's and you get something like -3, and then you go subtract the x's and you get a 0. So anytime you get that divided by 0, that's telling you you're going to have no slope, all right, when we're talking about lines. Positive slopes, these are graphs that will look like they're going uphill when you're going left to right. Negative slopes, we know, means that you're going downhill when you're looking uphill. If I give you a graph, you should have an idea, well, you should know whether it's positive, negative, and you should have an idea of whether that slope is going to be greater than 1 or less than 1. So if you remember, a slope of 1 comes up at a 45-degree angle. So if it's greater than that, it's more than 1. If it's less than that, it'll be less than 1 if it's flatter. The last two that we have here, same slope. If you have two slopes that are exactly the same, all right, that meant that you had to have parallel lines. And if you have slopes that are negative reciprocals, these are perpendicular lines. And you do have to be careful here because it is possible that you would get a vertical line and a horizontal line. Those are definitely perpendicular, but you would not get the negative reciprocal. All right, so there is one exception to it. Okay, again, I don't think you've learned anything new to this point. All right, just review of all these things that you learned. Okay, so let's take this problem here, and I want to do several things. So I've given you the equation to a line. You know that this is a line because let's see, my x1, my y1, I have exponents of 1 above. Let's start by finding out what the slope of this line is. I've given you a line in the general form. I can't tell what the slope is right away. I hope most of you aren't saying that the slope is 6, because it's definitely not 6. But what I need to do is I need to put it into a graphical form, into a slope-intercept form in order to do that. So we know what you've done in the last several years is that you've solved for y. Now, again, you can write out as much as you want or as little as you want, but you have to be correct here. So with the 6x, if you want to, you can just bring it to the other side and it changes the sign. That would give you a negative 3y equals a negative 6x plus 9. Now, if you're not too sure on that, you would just take your original equation and say, okay, I'm going to subtract away my 6x. These will cancel. That would give you the negative 3y. And over here, these aren't like terms. So you got a minus 6x plus 9. You would just leave it. Okay, doesn't matter to me. Most of you, by the end of the year, when you move terms from side to side, all right, not through division, all right, but if you're just moving it from side to side, it's just going to change the sign. Then we'll come back up. I've got to divide by negative 3, and everything will get divided by negative 3. So that would leave me at y equals 2x minus 3. Now, I created this so the numbers come out kind of pretty. They're not all going to be pretty. You're going to have fractions. You're going to have decimals. Maybe if the line had come out to be y equals 2/7 x plus 12/7. All right. If I get something like that, leave these fractions. All right. You're going to have to work without a calculator a lot in this class. All right. And we got to make sure that we can work with fractions. And you're going to see they're just easier to work with, especially these that don't, even though they are rational, they're not going to be very rational when you make them into decimals and turn them into decimals. So then the question says, what is the slope of this line? The slope, you can see, is the 2. And what's the y-intercept to this line? B value is negative 3. What's the slope to a parallel line? So if we know this is in the form y equals 2x minus 3, if I put in that y-intercept form, and we've already said the slope is 2, we know the slope to a parallel line has to be exactly the same. So it would also be 2. And if you didn't guess what the fourth question is, what's the slope to a perpendicular line? See, if my slope is 2, I need the negative reciprocal. The reciprocal is 1/2. The negative really means the opposite. Because this is a positive, I have negative 1/2. Now, some of you saying, Mr. Chubb, we've been doing this for 5 years. Some of you saying, oh, we're moving pretty fast at this point. Everybody's going to be in a different location. All right. This is stuff you've been doing for 5 years. If you are lost to this point, all right, this might be a time to come talk to me and we should talk about this class. I do have one more problem here for you. All right. But it is something to think about. Okay, finally, let's graph this. There's several ways to graph a line. Here's what I would prefer you do. If I have this equation and I already know what the slope-intercept form is, I would use that. The y-intercept, you told me, is negative 3. The slope, you have told me, is 2. All right, and think of that as being 2/1. Think of it as a ratio. Think of it as a fraction, in other words. So the y-intercept is -3. 1, 2, 3. That puts us the point here. The slope is 2. Now remember, that's the change in y over the change of x. That means every time the y goes up 2, the x moves forward 1. When the y goes up 2, the x moves forward 1. Up 2, forward 1. Up 2, forward 1. You can make as many, or really as few points as you need. You get a great idea of what that line would look like. Now, I would use a ruler most of the time when you have to draw lines, and we don't draw a whole lot of lines in here. We go into more advanced graphs, right, pretty quickly. It's hard for me to use a ruler in here without the whiteboard going berserk. All right, so I love that way. I love using the slope and the y-intercept, right? I hope that's one that you guys have used a lot in the last couple of years. Here's something else you can do. Remember at the very beginning, I gave you the general form. If you have the general form, you could come down, all right, make a little t-chart, and just find the x-intercept and the y-intercept. That's plug in y equals 0 to see what the x-intercept is. Plug in x equals 0 to see what the y-intercept would be. If I plug in x equals 0, I'm going to get 6 times 0 is 0, minus 3y equals 9. Divide by -3, divide by -3, I get y equals -3. Right? There's a point I know has to be on the line. When I plug in y is equal to 0, right? I'll go up above, I have 6x minus 3 times 0 gives me 0. I don't need that. Equals 9. Divide by 6. Divide by 6. I get x is equal to 3/2. Or 1.5. And then I can plot the x-intercept and the y-intercept. My y-intercept was 0, -3. 0, 1, 2, 3. And my x-intercept is 1.5, 0. 1.5, 0. And then I can connect those dots. If you notice, it's the same graph. All right. Now, the advantage here is if the original equation did not have to get put into slope-intercept form, if you weren't looking for that information, if all I wanted you to do was graph that, all right, finding the x-intercept and the y-intercept is a real quick way to do that. All right. If you already have it in the slope-intercept form, you might as well use the slope and the y-intercept. And then, of course, you can always do this. You can always come here and make a t-chart and say, well, I like to do things the old-fashioned way. I like to plug in 3 numbers, all right, for my x, and then see what those y's would be. If you plug in x equals 0, you get -3 back. We've already done that. If you plug in x equals 1, all right, as you will see, you get a -1 back. Trust me on that. And if you plug in x is equal to 2, you can get a +1 back. And then when you go to graph those, 0, -3, 1, -1, 2, +1. If you notice, you're going to be on the same line. So there's nothing the matter doing the old-fashioned way. You're going to find out that sometimes that takes a while. Sometimes you get a bunch more fractions and decimals that you have to graph. A lot of times it's just not the easiest way, even though it is the earliest method that you know. Okay. Again, I don't think you learned anything new. I reviewed a lot of different topics, though. Back in the algebra class, this took you like 2 weeks to get through all this different information. Tonight for homework, it's on a couple of different pages. You can see it at the bottom of the board here. And I look forward to seeing you tomorrow.